Hi, it is my pleasure to give you a presentation on USQL in the Azure Data Lake, talking about how we can scale out your database and big data analytics using USQL in a HyperScale environment, and focus on the .NET aspect of also allowing you to scale out your custom .NET code. My name is Michael Ries. I'm a program manager in the Microsoft Big Data team, owning, among other things, the USQL query language. So the first question that I always get asked is, why did we introduce USQL as a new query language? And the answer for that is that we were looking at the different use cases that exist in terms of doing big data processing based on our internal experience inside Microsoft with Bing, Xbox Live, etc., to see what are the different kind of use cases people have. And if we go through all those use cases, we notice that we need to be able to process any kind of data, going from completely unstructured data such as images over semi-structured data such as weblogs to completely structured data that people might want to do big data analytics over. In addition, we noticed that almost every one of those use cases needed custom algorithms and custom processing applied to that data, so that we needed to have a way of extending the capabilities of a traditional query language with giving you easy access to user code. And then last but not least, of course, we need to have a way of making it easy to scale both the standard query processing as well as your custom code out over large amounts of data without you having to necessarily be an expert in distributed system processing. So if you look at the existing database languages and query languages for big data, such as SQL, for example, of course, the benefit of those languages is that they give you the scalability abstraction by being a declarative language. But most of the time, extensibility is bolted on and doesn't have a native feel to it. So it makes it very complex and cumbersome to, for example, add your own custom formats and be able to add your own custom code. If you look, on the other hand, to programming languages for big data, ranging from languages such as MapReduce-like languages up to higher level abstractions such as, for example, Spark in Scala or Java, of course, you have a lot of extensibility because the programming language gives you this extensibility for free. On the other hand, the declarativity is not native. It's often bolted on. You have to write a lot of custom code and a lot of boilerplate code to basically be able to scale out the code for you. So it often makes it that the programmer has to care about the scale and performance. And even if languages add additional abstractions, such as, for example, link-based extensions or even embedded SQL expressions, they are still having a second-class feel to it because they are integrated into the language, and you have to be very careful about how you write your programs so that you still get the benefit of the scalability of the declarative part of your program. So we basically found that having a new language approach like USQL that gives us the declarativity and extensibility equally native in the language gives us the benefits of both, while avoiding many of the pitfalls that you have if you're just getting with one or the other. So USQL basically makes it easy for you by unifying your unstructured and structured data processing. It gives you the ability to unify your declarative SQL-based processing and queries with your extensibility using C#. And it gives you the ability also to combine queries that go against your local store, in our case, the Azure Data Lake store, as well as other repositories where data might live. And hopefully it will increase the productivity for you from day one, but also continues to give you high productivity once you operationalize your solution at day 100. So USQL was invented not as part of an overnight kind of light bulb coming up in my brain. It was coming out of the history of our big data processing in Microsoft. So it is based in a large part on Scope, an internal language that we are using over the last 8 years to do big data processing within Microsoft. We are basically lifting the C# integration model into SQL from that language, making it cleaner, simplifying it for external usage. Also, we are lifting the optimization and scale-out model that we have in scope, which is based on the Microsoft Research Dryad research from a couple of years ago. And just to show you that this language is actually already used in production, Scope today runs several 100,000 jobs per day over petabytes of data within the Microsoft Big Data environment. But we also looked at other things, such as, for example, Hive, to see what are the kind of capabilities that people want to have. And for example, from Hive, we basically took a look at the complex data types, such as maps and arrays, and added them to uSQL. Finally, we also looked at our T-SQL, ANSI-SQL kind of ecosystem that we have with SQL Server and with competing relational databases. And we basically made sure that all the SQL capabilities that people kind of expect, like group by aggregate, the ability to use windowing functions, the metadata model, and so on, is basically familiar to people that come to the language with a SQL background. So I mentioned that uSQL also gives us the ability to query data where it lives, which means that we can avoid doing data copies for certain types of queries. For example, a uSQL query, when it goes against Azure Data Lake Analytics, can read data from the Azure Data Lake storage account, as well as attached Windows Azure Blob Store accounts, and it can write back into those as well. But in addition, it also gives us the ability to do federated distributed queries against SQL databases living inside Azure. So SQL Server inside Azure VMs, Azure SQL DB, and Azure SQL Data Warehouse as well. So let me now show you a little bit what uSQL looks like. For that, I'm starting up Visual Studio. And in this case, I just started up Visual Studio. I have the Azure Data Lake tool installed, which you see here. There's a Data Lake option menu in Visual Studio. And now I just create a new project that allows me to do some processing. So what I do is I create a new project. With the uSQL extensions, I have a uSQL template here. I'm using the uSQL project to create a new project to show you uSQL. So let's do that. Now, as a next step, I also want to show you the data that I'm actually operating on. And for that, let me show you the Azure Data Lake Explorer that gives me the ability to explore basically files. I can invoke that from my Server Explorer window on the side. Let me just open my Data Lake Analytics account. I'm opening my own Data Lakes Analytics account called Emery's Kona. And open my default storage account. Inside my default storage account, you will notice I have a foldered file system. I just drill into my samples directory to go to a collection of tweet files. And let me open one of them to show you how the data looks like that I'm kind of going to operate over. So if I zoom in here, you will notice this file has 4 columns: date, time, who is tweeting, and what the tweet is. So let's do some interesting analytics over that data. For that, I'm starting to write my uSQL script. A uSQL script always starts with basically accessing some data from my store. If the data is inside a table, I can just say select star from table. If it is a file, I can schematize the file on read, which is what I'm doing here. So I basically say add t, which is the name for the expression, extract. And now remember the columns. We had 4 columns: date, let's just call this old type string, time, string, author, string, and tweet, string. Now I copy that from a location, that I will be copying over from the store. And I use, in this case, a built-in extractor. And since the file is a CSV file, I just use the built-in CSV extractors. So now I go over, right-click on the file, copy the relative path, put it into my script. So now I have schematized my data. Now I also want to output the data, so I say output add res for result to some file. Let's say output / result.csv. And I, of course, have to use an outputter, which is basically, again, a CSV built-in outputter. And now I need to do some transformation here so that it becomes a little bit interesting. So I set address first equals. And what I want to do is I want to count the number of authors per tweet, or tweets per author, as well as how many times a person got mentioned inside the tweets. So first let's do the simple group by aggregate, and then I'm extending the script with the tweet mentions as well. So let's see here. The first thing obviously is a group by over author. So I say select author count star as tweet count from at T group by author. And then I probably want to do the output order by tweet count descending, so I kind of see in which order they are coming. So this is a very simple script. I could now go and submit this script. I can submit this script by going up here, setting basically the location where I want to execute it. I can do a local execution, so I can do local debug and local development without actually having to have an account even. Or I can set the account that I want to submit it to. But I'm not going to submit it right now. I'm adding the tweet extraction as well. So let's add this as next thing. So mention, M for mention, gives me a select, and now I need to go and extract out of that tweet string every time somebody gets mentioned. Now people are getting mentioned with an @ sign in the Twitter sphere, so I basically have to extract all the words that start with an @ sign. How can I do that? Well, here the extensibility and the ease of use of using C# comes into play. If you look at the data type of tweet, it's a string data type. So I basically can just say tweet dot, and now I'm getting the whole universe of all CLR C# extension methods on the string data type. So I can now go and, for example, split my tweets into by spaces into words, and now I basically have all the words. Now how do I reduce my list of words to only those that start with an @ sign? Well, for that I can add a link expression, a link where clause that takes a lambda expression. X starts basically with, and the starts with obviously with the @ sign. And so now this gives me basically a list of all the words that start that way. Now a list needs to be wrapped into an array in new SQL, so I have to say new SQL array of string of this expression, and then I give it a name called mentions from at T. So now I have all the corresponding names extracted. Now I can continue and pivot all the mentions for each of the tweets, because there can be multiple inside a tweet, so that I have one mention per row. This is done using the probably familiar cross-apply expression that you know from SQL Server and T-SQL, or it's kind of equivalent to the lateral expression if you're more coming from a Hive background. So let's do this. I say again at M, so I can reuse a name as well. Select, and now I say mention, which is what I'm extracting. Let me also add a category here. So I say mention as category from at M. Now what I have to do here is I can apply a table-valued built-in expression called explode that allows me to take the mentions from the row set above and now basically pivot it into, and this is apply, pivot it into a row set where it's called mention. So now I have basically pivoted this. Now the next thing I want to do is I want to kind of combine my authors with my mentions. So I can do that by redefining my T into a union all. So I say add T equals select author, oops, comma. Now obviously I add an author category from my original T, and I union all this with the select mention and category from my add M. So now I only need to add the category down here to my group by clause. So I know who was the author and who was the mention, and I have my script. Now here the really important part is if you look at the script up here, it was very easy to add a fairly complex C# expression to my code. So now I can go and submit this. So I will just hit the submit button here. Okay, now we have submitted the script, and as you can see, Visual Studio's tooling gives me insight into what's actually happening. So it shows me that currently the job gets submitted and it's getting prepared, which means it's getting parsed, compiled, and then all the corresponding information will be put together so that you can scale out the query over multiple nodes. And once it has been submitted and parsed, you will see on the other side here a job graph appearing that shows what's actually happening when the query executes. So you see the job graph here now, and while this is running, let me go and show you what else we can do with this script. So as you can see here, I have a prepared version of the script that I ran before. The script is a little bit more complicated because I found out when I was running the script that I actually have to split it also according to punctuations, etc. But now this C# expression becomes very complex, and I kind of want to encapsulate that so that people reading the script actually know what's happening instead of having to decode the C# code. So what I want to do is I want to go and write and wrap this into a C# function. So I can do that by using what we call the code behind capability of uSQL's Development Studio. So what this is there is a C# file that gets added to every uSQL file that you create in the project, and that allows you to put your C# code into it. So let's take a look at that. What this is basically a definition of a namespace that contains a class, that contains a public static getMentions expression. And if you look closely at it, you will notice that this is exactly the expression that I had inside my script. So now what I can do is, inside my script, I basically just go and replace the more complex C# expression with an invocation of the uSQL method C# method that I have in my code behind file. Now how does that get pulled together? Well, when I submit the script, C#, the code will be compiled, will be uploaded to the Azure Data Lake metadata service. The script will be changed so that it does the registration for you, that it goes and actually adds a reference statement, and at the end it cleans up. And so I can basically use this for my own kind of development until I'm kind of happy that the code is well reusable and has no bugs in it. So what I want to do then is I want to go and take the code and actually publish it into the Azure Data Lake metadata service so that other people can use the assembly as well. So what do I do here is I go into my solution, add a C# project for uSQL, and then I basically just copy whatever I had inside my code behind file just into my C# file. Exactly the same code. Now I can go to my project here and select the register assembly option inside my menu. Let's do that quickly. And that now gives me the ability to upload the assembly file into my uSQL metadata service. Now once I've done that, I can now go and just reference, let me close it out. I can just go and add my reference assembly statement to my script as I have here on line 13, which then gives me the ability to just reference that code and import it and reuse it in every single script that I want to make use of these functions. Now note that the name of the reference assembly is a metadata name, while the name down in the select statement is just my standard C# namespace .class.method name. So this is kind of showing you a little bit how you can easily use C# capabilities inside your uSQL to do your custom processing. The ability is very powerful because it gives us a very easy way of adding the code through the C# type system integration, etc. But it also gives me the ability then to scale it out using the standard SQL optimization process and the ability to just tell the system how many nodes it needs to run on, and it gets automatically scaled out over all the data that you have inside your Azure data lake that you want to operate on. Now let's go back to the presentation and take a look at the uSQL language philosophy in a little bit more detail. So you see on the right-hand side here a simple script that is kind of a little bit showing you all the concepts combined in one script. So we start out with uSQL is based around the declarative language that we all know called SQL. It gives us the select from where that we are familiar with from SQL, but it also gives us group by, aggregates, joins, SQL analytics functions, etc. The whole 9 yards that you're kind of familiar with if you're using a SQL database today. And it gives us the optimizability and scalability that you would expect from such a system. But in addition, we also give you an expression flow programming style that might be familiar to people that have been using Pig in the Hadoop ecosystem. What it means is that each of the expressions get assigned a name, and then basically every time we reference the name, that expression gets inlined in that environment, so that in the end, a single script will give us a large single execution tree. Now, what is the benefit of that? Unlike in, for example, SQL or Hive, where every single select statement gets optimized locally only, in our case, we will get global optimization, which means, for example, that if you have a where clause on a later select statement, that actually can be pushed up into an earlier select statement because it reduces the amount of data that flows through your script, then the optimizer will decide to push that predicate up, and you will have a more efficient script execution. Another thing that we obviously have shown you already is that we can schematize and operate over unstructured data very easily just within the query expression. In addition, we also give you the ability to create tables that look like relational tables. They are stored inside the Azure Data Lake, and you can basically use them in the same way that you would use traditional relational tables inside create table, insert into table, select from table, etc. And now the extensibility. The extensibility is predicated upon that the type system is based on C#. Now what this means is now that we can very easily take our expression language to be C# as well. Now this might be a little bit surprising for people that come out of the SQL world, because obviously equals equals is the comparison operation in C# and not equals like in SQL, but it gives us the whole power of C# as an expression language. Not only that, it makes it very easy for me to extend C# with user-defined functions, as I have shown you earlier, and it allows me to add more complex constructs such as user-defined aggregators or user-defined operators. So you've seen my use of an extractor and an outputter that is built in, but if you have specific data formats that you know that you can process more efficiently, you can write your own extractors and outputters, for example, to do so. And we will take care in uSQL to take these user-defined operators and scale them out over the amount of data that you really need to operate on. Also, we have the ability, as I mentioned earlier, to federate queries against other data sources as well. So let me just give you a quick example of the expression flow programming style and what this really means. First, let me talk a little bit about what this means. You have automatic inlining of these USQL expressions. That gives you this huge operation tree that you kind of see the shape of here on the slide. Now, the execution plan then takes that and optimizes that into a physical plan that then gives you the ability to basically see what it means to scale this expression out. Now, I have a sample job here inside my Visual Studio that I want to go and show you in a little bit more detail. So this here is a recording of a job that we have run inside Azure Data Lake using USQL that operated over 11 terabytes of data and wrote out about 10.5 terabytes of data. The job itself was a job running on our own telemetry data, was decomposed into about 12,000 units of work that we call vertices, and we ran the job with a degree of parallelism of 1,000. The job itself took about 40 minutes to run and looks like this. Now, you don't have to see the details, but let me zoom in a little bit to kind of show you a few interesting aspects. The first aspect is that, for example, here you see that you operated over 97 files. Here you operated over about 120 files, etc. So this could all be done in parallel. And then each one of these jobs basically run and completed. Now, obviously, I'm not sitting there waiting 40 minutes to see what happens. So we have a feature that allows me to download the job profile. There's a button up here that basically allows me to download it. I already did, so let's cancel out. And once I do that, I can do a job playback. What this does is it's rerunning the job within about 30 seconds. Now, if I don't want to see if the job just completes, but I also want to see where a lot of time gets spent, I can, for example, change the display to show me the execution time. So let's change that. And now I have a heat map. So now you can see that I can scale out my processing over, in this case, 11 terabytes of data, operate on it in less than an hour. And not only that, I can go and basically drill in and see what is really expensive and which paces of the script I might go and optimize a little bit more. There is more to that. For example, I can go into the diagnostics. The diagnostics is basically some aspects of the job that we observe to give you as the end user information about what you could improve. Now, in this case, there are no warnings. There is no skew in the processing of the individual nodes. There is no overly expensive use of memory. But let's look at the resource usage. So I click on this link here and see what the actual resource usage is. This shows me the actual execution characteristics of the graph. And it tells me that it took about overall 35 to 36 minutes for the execution here that was observed. The green part shows me how many jobs were actually inside the queue waiting to get executed, so it wasn't too bad. And then the red line shows me what was actually running, and the blue line up here at 1,000 is basically how much resources I gave. Now, in terms of payment, I'm paying the amount of time times the amount of resources that I specified, so 1,000 times whatever unit I'm paying for one of those units. So now I can see that I have a lot of space up here that I might want to optimize. For this, the tool has a new usage modeler component I can click on that kind of per default shows me if I just want to be the fastest in executing, then by using 2,400 nodes, I could have executed this whole thing in about 1,400 seconds. But this is an expensive job, so let's see what happens if I reduce this to 1/10 of the resources. If I reduce it, you obviously see utilization gets much better. And so I'm using, in this case, 10 times less resources, but I'm only 2.5 times slower than if I would have run it with the fastest mode in this case. So as you can see, not only do we have a language that is easy to use and get started with, but we give you a lot of tooling that makes it very easy for you to actually then also operationalize it and analyze the jobs while you're deploying them and using them on a daily basis. So let me conclude now and tell you, kind of summarize why we think USQL is a great language for you to do big data processing. It is a very simple language to use, especially if you have SQL background and a fairly introductionally understanding of C#. You don't have to be a C# expert, but it's very easy to kind of get started. It unifies these two things to make you very productive in order to process big data. It also gives you the ability to query both structured and unstructured data and query both local data and remote data. As a call to action, I would like to recommend that you are signing up for an Azure Data Lake trial account. We are currently in public preview. And give us your feedback either via the feedback page or the link to the survey on this slide. Also, you can obviously go and download the tooling, the Azure Data Lake tools for Visual Studio. And if you are having a Visual Studio installation, even a Community Edition one, you can run USQL queries local on your machine for free to try out how USQL actually behaves and how you like it. There are a lot of resources that we can point you to where you can either engage in the community, read up on the language, read up on Azure Data Lake overall, and can also provide us feedback or ask us questions either on Stack Overflow, MSDN forums, or our user voice page on the ADL feedback link that you see here. In addition, I would recommend that you are checking out the rest of Build on Channel 9. There are a lot of other interesting videos. And you can go to the Microsoft Virtual Academy online to continue your education. Later this year, we will have a couple of USQL-specific deep dives available on Microsoft Virtual Academy as well. Thank you very much, and enjoy Build.